Unit 2, Lesson 2, Exponential Ratios. I can create an exponential formula given 2 points. Last unit, we talked about linear functions. Linear functions change at a constant rate. So in other words, you add or subtract the same number each time to get a linear function, while exponential functions change at a constant ratio. So in other words, you multiply by the same number to get from point to point on an exponential function. So when we are trying to develop exponential equations, we're trying to look for ratios for our b value. So for example, an exponential function contains the points 2, 600, and 4, 2025. Find the formula to represent the function. If you think back to the other day, our formula for an exponential function is y equals a times b raised to the x. Yes, x could be replaced with t and y could be replaced with f of t or f of x, but this is our general formula. And we would need to find our a and our b value. It's much easier when you're given 2 points to start by finding your b value. And for that, you need a ratio of your 2 points. These 2 points are not right next to each other. It's not 2 and 3, where we could just say, well, 600 times what gives us 2025? Because the x values don't go together. We skip between 2 and 4. So we need to find the ratio that we're multiplying by each time. In order to do that, we would be saying, if we took our b value and raised it to the second power here, like in our formula, b raised to something, b raised to the second in this case, should give us 600. Well, if we take b and raise it to the 4th power, we should get 2025. So we're going to write that as a ratio to see what our actual b value is. I'm going to put my higher exponent on the top of my ratio just because it's going to make things a little bit easier for me. But if you're more comfortable putting the lower one on the top, you can. So b to the 4th over b to the 2nd equals 2025 over 600. That's our ratio. Now we just need to solve for b. If you remember your rules of exponents, b to the 4th divided by b to the 2nd, since we have the same base, we can just subtract those exponents. So 4 minus 2 would give us 2, and we would have b to the 2nd equals 2025 divided by 600 is just a calculator problem, and that gives you 3.375. Now to find my b value, I just have to get rid of that exponent of 2. The opposite of squaring is square rooting, so I'll go ahead and square root. And I will find out b is equal to 1.837117,302. Oh, sorry, 307. So that's my b value. And once I have my b value, I can very easily find my a value. I'm given some points here. I know that if I do a times b raised to the second, that x value, I should get 600. So if I plug that in, my y value for my equation would be 600. My b value is what I just found. A, I'm not sure of yet, so I'll just leave that. And I know if it's raised to the second power, I'll get that 600. You could use your other point. You could plug in 2025 for your y value and 4 for your x value. I'm just choosing this point. So now if I do 600 divided by 1.837117307 squared, I will find my a value. And I will find a is equal to 177.778. So my formula would be y equals 177.778 times 1.837 raised to the x power. At this point, it's okay to round to 3 decimal places for your b, but when you are plugging in to find your a value, so in this step right here, you don't want to round too early. You want to keep all of your decimal places so you don't have any rounding error. Now let's take a look at our next problem. At time t equals 0, turtles are released into a wetland. We don't know how many, so we don't have an a value yet. When t equals 4 years, a biologist estimates there are 300 turtles on the wetland. 3 years later, the biologist estimates there are 450 turtles. Let P represent the size of the turtle population in year T. Assuming the growth is exponential, create a formula to model this situation. Use the formula to predict the number of turtles 15 years after the turtles are released. So we don't know that A value. So we're going to have to go through that same process we did last time. So let's take a look at what points we actually have. So T equals 4 years, there's 300 turtles. That's kind of like saying the point 4, 300. And then 3 years later, 4 plus 3 would give us 7. There's 450 turtles. So here's our 2 points. And we're going to go through the same process we did last time. First, we should set up a ratio. So b to the 7th, that's my x value here, over b to the 4th, because 4 is my x value here, should give me 450 over 300. And again, because this is exponential, we should have ratios. We don't want that just strict slope of y1 minus y2 over x2 minus x1. Here, we can now go through our divide. So b to the 7th over b to the 4th, again, think about that subtraction. We have the same base, so b, 7 minus 4 is 3, equals 450 over 300, which should give us 1.5. Now, b to the 3rd, we need to take the cubed root of this. When we take the cube root, we will get b equals 2.247, 44871. So again, we can now pick one of our points and use that to plug into our y equals a times b to the x formula. I'll just go ahead and pick my 300 point. So my y value is going to be 300. My a value I don't know yet. B is what I just found. And x is 4 for that point. Now again, I'm just going to divide to get a alone. And what I'm left with is a equals 133.333. So my formula will be, I think in this one, we'll use P, oh, yep, P for our population, sorry. So P equals 133.333 times 1.225 raised to the t will model my population. Now to predict the number of turtles in 15 years, or sorry, 15 years after it was released, we're just going to plug in 15 for t. So we'll have 133.333 times 1.225 raised to the 15th. And this you can just go ahead and plug into your calculator to find your P, or your population, in 15 years.